Hello, class. My name is Rodney Norman, and I'm here to discuss web application firewalls for ECU. So today we're going to give a kind of a general overview of what we'll be discussing today. We'll talk about what a traditional network firewall prevents or doesn't prevent. We'll talk about what a web application firewall prevents. We'll give a review, and then I'll give you my overall conclusion. So let's start out with talking about what a generic network firewall is. Um, of course, some may know, some may not know that a web application firewall consists of either a host, which is on the system, sort of like a window firewall, or it could be what we want to call a network firewall, something that traditionally sits around the border. Your Fortinets, your Palo Altos, your ASAs type devices, and basically they're there to prevent outside users from coming into your network. And on the reverse side, if you don't have it set where anybody can go outbound, you can actually use it to prevent people from going outbound to any site they want to, or open up any port outbound. I know currently today at my current job, really only 80 and 443 is allowed. I mean, I can't RDP out, I can't FTP or anything like that. So it just depends on your organization how locked down it is. So here's a picture. I just want to give you kind of want to explain it first and then kind of give you a picture of what I'm talking about. So basically, the brick wall right there symbolizes your border firewalls. You know, we kind of went through the various vendors. It's just determines what flavor you like. But basically, you got three laptops on the outside of the perimeter there trying to gain access to the server. But also inside the network, you have PCs that are able to talk to the server via the network. So, you want to first stop people from gaining just anybody coming into your network, because if you don't have a web server or anything like that for a user to come in, nobody should be able to come onto your network from the outside. You should be able to block every port. If you're opening up some kind of web services, then you'll have like 80 and 443 so people can get to your website if you're hosting it on campus. But then also you have to look at your PCs um, inside your network. Those guys consist of a what they consider a host-based firewall that actually sits on those guys, where you can control the firewall there and stop or deny access outbound from the PC level. So just depends on how granular you want to get and where you want to stop particular users. I mean, in traditional networks, you always see the the border firewall is always up to prevent various people from getting inside your network. Just depends on how in depth you want to get on the host-based level on your actual PC uh, to see if you want to stop somebody from there. So let's look at what a network firewall can prevent. So this is the wall that we kind of showed in the previous slide. I want to kind of discuss what it can prevent. So the first thing is network scanning. So if I'm at home with a Linux box um, and able to get Metasploit and Nmap working on machine, I can say, okay, you're at this particular website, and I'm going to send my Nmap on you and see what you respond back to. So of course on this one, we actually see port 2180, 443, and 3306, which is like a SQL server that are allowed inbound. So we actually kind of did this in class. I think it was 6885, where we were using a Linux machine um, to probe a host to see what he will respond to. So then the attacker knows, hey, if I want my way into this particular network, I need to use 80, 443, 21, or 3306. So this is one thing a traditional network firewall can stop It works at kind of at the layer 3 level IP and port. You can say, hey, I only want people um, coming into my network from the outside of my network with these particular ports, and it's okay if they come in. So that's one thing it can prevent. The second one would be denial of service. So if I'm home on a box, and let's just say I have kind of got some some, as they call them in this depiction, zombie computers, but I just call it infected host out there. I send a pin, I send a ping to them and get them to magnify that ping. So instead of sending one, it may send 100,000 to you coming to your site. Just depending on how big your internet pipe is, how strong your particular host is, I can cripple your ability to allow people inbound. The point of this is just to be able to take you offline. I'm not really trying to get any data from you. I just basically don't want your site available at all. So when I go to your site, I want it to be crawling or usable or cannot be used at that time. Um, so these are two things that a generic, what I call a layer 3 layer firewall, is known to prevent. So let's look at some issues that these firewalls have. So the first one, that these guys only operate at layer 3, layer 4, and as you can see here in this diagram, we have an attacker here. He's trying to set up a three-way handshake, so he sends us in, and because we're allowing port 80 or 443 open, he's gonna send. He said, okay, I allow anybody in on port 443, so I'm gonna allow that handshake. He comes in and he's able to talk to my server internally. The server says, okay, I see you saying, I'm gonna send you an acknowledgement back. And then once that attacker gets that reply back, he'll send a send back, and he can proceed to see if that particular server is vulnerable. Um, Initially, these type of attacks wasn't happening. They were more of port type attacks, but nowadays these attacks are happening within a 443 packet. So, of course, that particular transaction is encrypted to everybody but you and the server. So a lot of these firewalls or IPS, IDS don't have the ability to decrypt that to be able to see that type of traffic. So these are, I guess, new ways attackers are getting in. So one of the things that I actually saw for myself was a brute force attack, and this is something that that happens to a generic firewall. You're able to set up a regular, like say a TCP session, then the attacker says, okay, I got all. It's almost like a dictionary attack. Say all those username and passwords that was stole from Target. A lot of users use the same password and username for every account they got. So they set that script to run, and it basically goes down. You see here, he was trying all kind of admin plus passwords, and he finally got in and got gained, uh, found an account where he could at least start there and get either admin level or root level access to a host machine or AD account. So these are things that we need to look at now going forward with these type of attacks. So now comes in the web application firewall. Um, I'm not 100% sure on how long they've been out, but I know we put one in maybe 3 years ago, and they were kind of pushing them, but until we got uh, a brute force attack, and kind of going back to the other slide, I know it's not considered a denial of service, but what we saw when they sent those that kind of dictionary attack to our servers, the back end servers that was hosting the request, they kind of came down to their knees almost, because even though it was asking the server, hey, is this account a valid account, or is this username password combination? Every time it hit the server had to go back to the backend database to request that. So even though it was not like a network, just volumetric type of DDoS, it was able to um, almost stop our servers from being able to retrieve that information. Luckily, we had like 12 servers total. And at the initial time of the attack, we had 4 running, and we the good and bad thing is we turned up more, which allowed the attacker, which gave the attacker more resources to try more passwords, but at the same time, it also kept violent members from being able to log in. When if we only had those 4, it'd have brung those 4 down to their knees because they were trying to go check those accounts so fast that their CPU and memory utilization start to spike. And we actually got a call from the server team asking if if we were doing something on the network, because it was kind of one of those things you don't know until they start looking at the logs, and they can see that all these fictitious users were trying to gain access to uh, bank accounts. So uh, let's not go too deep in that. So right now we have web application firewalls, and basically this guy works at the application layer, so he's able to inspect HTTP, HTTPS. He can actually stop some of these brute force attacks we've seen, SQL injections, cookie poisoning, those type of attacks. So as you see here, this guy now, so in this scenario, they don't depict it, but most people would have a perimeter firewall. But as you go to the application, a valid request comes in, he's allowed. But when the SSS attack or SQL injection is sent by the WAF, uh, we had the ability to stop it there. And like you say, WAFs are only good as the people program them. Sometimes they have some automated stuff that can be turned on to stop generic attacks. But some of this stuff you had to do some due diligence to be able to mitigate some of these attacks. But it gives you the ability that you wouldn't have in a traditional network firewall that works at the layer 3, layer 4 from the OSI model. So I think you know getting this on the network will give you the ability to start mitigating the attack or see the attacks, and then you at least have the ability to do something with them once you see. So let's talk about kind of stuff I kind of put up. This diagram kind of depicts what we kind of talked about earlier, but basically you have the ability to protect from future hacks. And like I say, some of this stuff, some of the WAFs, I know the one we use, it has the ability, it kind of looks at, traffic coming in and say, okay, hold on, I see a spike here that, normally on a non-payday, traffic's running here, it's running a little bit higher than today. I'm gonna send out an alert and just get you to check it out and make sure that, this is not an anomaly. Or you have the ability to create specific rules. So if something comes out day 1, we have the ability, you see in 2, we have the ability, if a server is having issues that we're hosting behind this particular WAV, we can go create a signature right then if we understand what the signature is, and we can stop that traffic before they get time to patch. Patching schedules don't run exactly how we wanted to run, but I'm able to go in there and that same day create a patch to give the admins time to patch their Linux or mostly Microsoft servers behind us. So and then 3, brute force. That was one of the reasons how we got the WAF in our environment so fast, and actually we put it in fairly quickly once we saw that attack coming towards our network. So I thought it was pretty good. And then the last one is mitigate DDoS attacks, and this is distributed denial of service. And like I say, the way I saw it wasn't a volumetric from a network perspective, but it was more of a resource denial of service attack, because if they didn't turn up the rest of those servers, they wouldn't have been able to service the real members trying to get in. So I thought that was pretty good that we had the ability to mitigate that type of traffic coming into our network. So let's talk about the different types of WAFs. Right now we have uh, a network base, a host base, and a cloud based solution. So I mean, most users would want it as far as away, so that would be cloud. Um, of course, some places they don't believe in the cloud or don't trust the cloud or not sure about the cloud. So I just wanted to let you know that alternative is here. We can every everybody trying to get to our particular URL we're hosting, we can actually via DNS send them to a scrubbing center or a cloud-based WAF out there in the depending on what vendor, we can send it to their particular scrubbing center, and then that traffic can come to us afterwards. I mean, if it's up to me, I think that's the best solution. You want to mitigate that as far as away from your network as possible. But the second one will be a network base, which is kind of sits, before they get into your network or get to your application servers. That would be my second recommendation. But um, like I say, it just depends on the particular company, and that's the way we went. And of course, the last one would be a host that means on the application servers itself. So that means you made it pretty far into the network if you're getting to the application server. But sometimes just depends on resources, money. That may be the best one. And it's one not listed up here, but there is one a virtual, which is still could be network based, but it runs on a probably like a UCS or some kind of uh, server, or it could be standalone. But the particular one we had was a VM on a UCS environment, and we spun them up within an hour, got an OVA, and was able to start mitigating the attacks fairly quickly um, until we could get a true like piece of hardware there for a true hardware network based WAF. So let's just review what we talked about earlier. So kind of what we see the differences between a WAF and a network firewall. And like say, I'm not going to read them line by line, but some of the big ones that just the OSI model layers where it works at layer 7, the presentation layer, and the network firewall work at the network and transport. And like you say, the layer 7 is HTTP, HTTPS. Layer 3, layer 4 is IP and port. So that's like TCP, uh, TCP IP. I guess in our generic world, it'd be like if we had a public IP address of like 192.168.1.1 port 443. That's what this particular firewall, we have a rule in there that says, hey, anybody trying to get to this IP address on this port is allowed. Anybody else trying to get to 192.168.1.1 port, let's say port 80, which is unencrypted web protocol traffic, I would block that. Let's just see application layer versus backend layer, and like you say, the target objects. You can kind of see it protects HTTP and HTTPS, where, like you say, on the network side of that, it's just basically there to protect users from port scans, denial of service type attacks. Um, but like I say, it's a good list of kind of going through what each one does, and the difference between them. And you can see over there on the side, it kind of gives you what they do, what they don't do type deal. This is like some other things I found on a I can't remember the website, but I'll put it um in our when we post it. I'll make sure I have it as one of the links down there so you can go see it. But this was just kind of things that they saw different between a network firewall and a web application firewall. Um, I'm not, like I say, I'm not gonna read them verbatim, but basically, like I say, your network firewall is there to just stop generic users from doing just seeing if they can get to an open port, see what they can get to on that port. Um, where a WAF is going to be what I consider more intelligent, to actually look at the actual packet and see, okay, this guy's, even though he's doing a HTTPS or HTTP request, in here he's trying to inject, Java and do a SQL injection on me or towards the server, and you have the ability to write or watch it. But these are kind of the things you need to look at when you are thinking about a generic, well, not generic, but a network firewall versus WAF. So, just in conclusion, um, when I look at both of these guys, I think everybody I'm talking to in the class is going to have a network firewall just at the border. But I also like to be able to put a WAF behind that. It kind of gives you the ability to initially stop, what we call our script kiddies, just somebody that just starting, they're just out there using it, Nessus or Mmap or something like that, just scanning, see what is vulnerable or see what's open. But then, like you say, when you get those guys who are like the brute force attacks, that that was, if we didn't have a WAF, we would have never saw that traffic, and why the TPs were, I said TPs, why the backend servers were going, that had a real big spike. The admins wasn't sure why the particular server resources was getting used, but it was because a hacker was trying to do a brute force attack with password, just I guess out of a something like Target, just like a dictionary attack. Someone was the username. Someone was actually real accounts that they got. So people accounts got locked out. We had kind of a rule that after three tries you would lock your account out. So we kind of knew who had their username on that particular list, may use a different password. Most of them we were able to find out and talk to them about changing their password and possibly a username. But like you say, I would suggest you use both. Um, if you had the resources, there's no better than kind of layering protection on. Like say you stop a lot of just layer 3, layer 4 attacks with a network firewall, and then you come right behind that when you get somebody more advanced. Then you have the layer 7 application firewall looking at traffic. And in our actual environment, we have a load balancer sitting in front of it, so we're able to de-encrypt that traffic and send it to the WAF unencrypted and let it look at it and inspect it before sending it back encrypted to the server. So I think it's a pretty good scenario. But thanks for listening to my presentation. Look forward to your questions. I'm on the having a brain freeze, but looking forward to seeing your questions. Thank you.